Welcome back. Today we're going to be looking at factoring. So hopefully this is a little review from back in the day of 9th grade, 10th grade, 11th grade, whenever you did it. Shouldn't take too long, but we're going to look at 3 different ways to factor. We're going to see how some of them can be used in different cases and how the third one really can be used anytime. And so if you're going to remember one of them, the third one is the best one. That's the goal for today. Hopefully by the end of this, you've got the quadratic formula down in your brain, and you can take care of any factoring that may come your way. So let's get started. Don't skip the next 10 seconds. I know it's easy to go skip, and skip this creed, but you know what they say, if you can say the creed, you can get 100. So today's a new day. I can read and remember well. I can develop my viewpoint and apply it correctly. I have eyes to see, ears to hear, and a mind to understand. It might not be easy, but it's worth it. All right, let's factor. So we're going to look at today. Well, that's not working. We're going to look at today factoring in polynomial equations, usually only to get started today. I don't think we're going to go past x squared, usually with the greatest term of x squared. Yep. So here's a quick definition of what we're looking at. And if you want to define some terms in your brain real quick, we can define coefficients, right? We can define variables of different orders. Variable, and this needs to get fixed. It will be fixed by the time this is posted. That's a C constant term, not an extra x. We already have an x term. So we're looking at a quadratic equation with variables and constants. Here's C, which is called our constant, but also a coefficient of the x term with the power of 0. So we're looking at a factorable thing. Now, you might have some zeros thrown in there, right? You might have like a missing middle term or something, and we'll see that special case. But a lot of these tactics will work for no matter what you're doing. So this is a quick review. You don't have to know it. This is just, oh, I remember seeing that. This is for you to remember if you've seen it or not. So you break down your C term, your constant term, into all of its factors, or the things that multiply to get your C. So that's 1 and 10, and 2 and 5. And then what I like to do is throw a plus or minus in front of it so that I don't forget that -1 times -10 is also 10. So those are the only factors I can think of. So then my goal is to go and look at this term, look at this B term, and say which of these add up to get me that B term. So 1 and 10 can add up to get positive 11 or negative 11. Right? Or positive 9 or negative 9. Any of those 7? Nope. So I'm going to cross it out. Say no good. And then I'm going to look at this 5 and this 2 and say, what can these add up to be? Well, I think just by looking at it, I can kind of see -5 and -2. -5 and -2 do add up to get me that -7, so that's where I'm going to stop. I'm going to say, okay, I got it. So then we can write our term in 2 factored out parts. X minus 5, that's where I got that -5, and x minus 2, and I'm going to set them equal to that same 0. So that's kind of the review of factoring. Now that equation is factored out, those aren't solutions, those are factors. If we wanted solutions, we would apply the zero product principle below, which we're going to get to. But a lot of you might have seen that makes your solutions kind of the flip of those numbers, right? That makes your solutions, x equals 5. And x equals 2, or the set of 2, 5. Cool? You don't even know how to do it, but if you do know how to do it and your brain's like, oh, I remember that, that's awesome. That's kind of like a review to see if you've seen it before or not. All right, so let's get started into what that all was and go a little bit slower. So the zero product principle basically says, hey, if I've got something, could be a number, could be a long term, could be in parentheses, could be not, and then some other thing multiplied by each other, then either that blue circle, that A term, or number, or anything, it better be 0, or that red circle, that B term, better be 0. There's no other way for this to happen. So how that would apply to what we just did is one of those sides has to be equal to 0 for this to work out. Either this red term has to be equal to 0, or this blue term has to be equal to 0. And that's how we solve for those solutions. So let's see how this plays out. First things first. Step 1 says, if necessary, rewrite the equation in general form. I'm going to go ahead and do that. I'm going to go ahead and make a little note in my brain that there's a c there, but the c is 0 because it's missing, right? So we've got our a term, our b term, including the negative sign, and then a c term of 0 because it's not there. So I want my brain to just know that so I see it. So I can see the types of problems that come up. Factor completely. So what we're going to do first is we're going to factor out common terms. So what terms are in common? I definitely think 2 is in common because 2 and 4 have 2. And then 1x. So what I'm going to do is I'm going to kind of like reverse distribution. It's factoring. I'm going to factor out a 2x. And that leaves me with 2x minus 1. Right? Looks good to me. Nope, not 1. Yeah, that's right. 2x minus 1. And then we're going to set it equal to 0. And now what we're going to do is apply that zero product principle and say, well, one of those on either side of that multiplication better be 0. So either 2x equals 0 or 2x minus 1 equals 0 or both. So let's see what happens. If 2x equals 0, we're just going to solve each of these separately, right? So let me move that over. We're going to solve first things first. We're going to divide by 2 on this side. End up with an x equals 0. Okay, let's solve the second one. Add 1 to both sides. 2x equals 1 divided by 2. X equals 1/2. Okay, we have two different solutions then. They're not the same solution. So then we can write our solutions as a set of 0, 1/2. Not too wild. So what we did in this new step right here was apply the zero product principle, where that was the red term, and that was that term in black. And we said applying this zero product principle says either the left side equals 0 or the right side equals 0 or both. Let's see what happens. And that's all we did. Okay? Let's see. The rest of these I've done for you. So let's hop down to the square root property, where we're looking at a sometimes you're missing your b term. All of these have something in common, that they're missing their b term. They're missing that middle x term. So this is your a term because it is attached to the x squared. This is your c term because it's a constant by itself, but we're missing our b term. What that does is it's really nice for us because we could apply the quadratic formula and get the correct answer. But instead of doing that, we can just do it's like a little shortcut almost, that we can just apply some properties of arithmetic, that DCMAM thing, and solve it on our own. So if you jump straight to factoring, you're like, oh, I can factor it. That's A-okay. You'll get the right answer if you do your arithmetic correctly. But what this is just a shortcut with the square root property to kind of show you, oh, we don't have to do it that way. So watch this. Plus 15, plus 15. This is me just isolating x by itself. Divide by 3, divide by 3. X squared equals 5. Now to get rid of a square, the opposite of a square is a square root, and I always draw that little line right there that I just drew to cancel it out. And then if you square root one side, you better square root both sides, so we're left with x equals 5. Oh, that's not true. I just wrote it. X equals the square root of 5. And now we read that definition right up above, and it says if you've got a variable squared, if you're working with a variable squared and you square root it, then we're going to add this plus or minus, because we're going to say we don't know whether it's a positive or a negative that got us that squared. So we're going to say both. So I'm going to add this plus or minus right there. The reason why, if you really want to go back and check that, is because plus square root of 5 squared gets you 5. But also minus square root of 5 squared gets you 5. So we don't know which one it ended up being. So we going to go ahead and account for both and say x equals plus or minus square root of 5, also known as the set of plus or minus the square root of 5. And that's the square root property. But if you forget the square root property, or you forget that easy factor, or the little shortcut, you can still do it in the other ways. All right, here we go with completing the square. This is my least favorite way of the three, but it's important to know and important to recognize. So basically what it's doing is it's saying, hey, let's force this thing to be a nice, neat number, right? By picking this special term, b over 2 squared. So we're going to divide by 2, square it. Take b, divide by 2, square. Take b, divide by 2, square. Take negative 7, divide by 2, square. Take 3 over 5, even though it's a fraction, divide it by 2, square it. So I think this first section, we're just going to do that. We're not even going to do completing the square. We're just going to say 8 divided by 2 equals 4, then square it, equals 16. Cool with that? Okay, let's do it again. Negative 7 divided by 2, that's the first step, then square it. That's going to be 49 over 4. Can't reduce it. 3 over 5 divided by 2 is 3 over 10. Square it, probably 9 over 100. This is just to get used to doing this term. 6 divided by 2 is 3. Square it is probably 9. Absolutely. All right. Let you do the last two on your own, and then we're going to see why. Why do that? It's so that we can complete the square and make this a nice, easy term. If we do that, our term always works out super nice and super easy. So watch this. Okay, don't worry about the whole big equation. Just ask yourself, what's that b term? Negative 6. Divide it by 2. Negative 6 divided by 2. And square it. That's just what our formula told us to do. So that's going to be something like negative 3 squared, which is something like 9, right? Okay. So what that's saying is, wouldn't it be nice if the c term was 9 instead of, it looks like it's 4 right here, right? We've got our a of 1, our b of negative 6, and our c of positive 4. Wouldn't it be nice if our c term were 9 instead of positive 4? Well, here's the crazy thing. We could force it to be, right? Because what you do to one side, you have to do to the other side. And how do we turn a 4 into a 9? We're just going to force it. We're going to kind of like strong arm this equation to be what we want it to be by adding 5. Because we just said our nice, neat number would be 9, but we have a 4. Let's just add 5. But what you do to one side, you have to do to the other side. So I'm going to add 5 to the other side. And I'm going to be left with x squared minus 6x. We didn't change it. We just worked with it. Plus 9. We didn't change that b. That's an important note, is we didn't change the b. We just used it to find a nice, neat number. And that equals 5. Well, now we can just look at this factor and say, okay, well, what are the factors? And this is why it's super nice, is because the 9 breaks down into easy factors for that negative 6, right? Negative 3 times negative 3 gives me 9. Negative 3 plus negative 3 gives me negative 6. Looks good to me. So what we're going to do is we're going to say this is technically x minus 3 times x minus 3, which can be written as x minus 3 squared. Absolutely. So now we've got something where we can apply that last formula, that square root property, because we can get rid of that square with the square root, right? And what you do to one side, you have to do the other. Square root of 5, that's the exact same thing we just saw a second ago where I messed it up. So we've got x minus 3 by itself, plus or minus the square root of 5. Cool? Almost there to get x by itself. We're just going to add 3, and I'm running out of room, but it looks like we're going to be left with x equals positive 3 plus or minus the square root of 5. Also known as the solution set of 3 plus or minus the square root of 5. Zoom out a little bit, let you look at that. Not too crazy. I know it's messy, I know it's ugly, but if you divide by 2 and square it, and then you force your equation to have that number at the end, it's always going to work out nice and neat like that. Note, we're not going to do the whole thing, but I will make a little note. See how this one has an a in the front? That makes it kind of ugly, right? We don't like that. So if we go and look at these instructions one time, it says if a, the leading coefficient, is not 1, divide the whole thing by a on both sides to get it to be 1. So watch this. We're just going to divide the whole thing by 9. Divide the whole thing by 9. We're probably going to end up with x squared minus 6 over 9, which you can reduce, minus 4 over 9 equals still 0. And then we'll just work from there. Our special b term would be negative 6 over 9 divided by 2, square it. All right? But this is where the meat of it comes in. This is the main thing for the whole day. Like if you forget everything else we learned today and you can just memorize this, you're in good shape. You're going to be A-okay for everything we do. So here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you Google on YouTube and you go and look for like a Quadratic Formula song, or you type in Quadratic Formula, Pop Goes the Weasel, from like the kindergarten, that elementary school song. You'll find a million different TikTok dances, and you'll find a whole bunch of different songs and ways to memorize this. But the goal is, I hate saying that you have to memorize it, but you do have to memorize it. Like, you really just have to memorize this equation because it's so easy to use, and it applies to every quadratic ever. So let's just see what happens if we apply it. We've got an A, and we're going to make a note that we're always going to grab the sign from in front, not behind. We've got a B, grab the sign from the front. C, grab the sign from the front. So A equals 8, B equals positive 2, C equals negative 1. Okay? So we're grabbing the sign from the front, and then we're just going to literally plug them into that equation. So the equation, if you can sing the song, is negative B plus or minus the square root of B squared minus 4AC all over 2A. And then we're just going to slowly. You're not going to mess up the college algebra section. What will mess up is the arithmetic, like the adding and multiplying and subtracting numbers. So just go slow, use parentheses. So watch, every time I plug it in, I'm going to change the color. So negative 8 plus or minus the square root of 8 squared minus 4 times 8. Oh, that's not B, that's A. There we go. You were yelling at the screen probably. You were saying, no. B is 2. Negative 2 plus or minus the square root of 2 squared minus 4/8 times, what's the next one? Negative 1 all over 2 times 8. Let me check, make sure, because I did make a mistake. Negative B plus or minus square root of B squared minus 4AC all over 2/8, which is A. Perfect. And now we just do a little bit of arithmetic. So this is x. I'm going to go ahead and set this equal to x so you don't forget. These are our two x values. Where do the two values come from? The plus and the minus. So let's reduce it a little bit. We know that 2 squared is 4, right? 4 times 8 is 32. With the negative, it's probably going to turn that into a whole positive 32. Bottom's probably going to be 16. So if we reduce that a little bit, we got negative 2 plus or minus the square root of 4 plus 32 all over 16. These all look like nice 16e 32 4 numbers. Those all look pretty nice. So x technically equals negative 2 plus or minus the square root of 36. Oh, perfect square, which is awesome. You know the square root of 36 is 6. So you don't need to think about, oh, I need to add the plus or minus. It's already there. The formula added it for you. If it weren't there, we would need to be thinking that in our back of our brains. But since the formula had it for us, we're good to go. So now here's where we're going to break this into two equations, because we want to get two different solutions. So one of these is going to be the plus side, and one's going to be the minus side. So we got negative 2 plus 6 over 16, and negative 2 minus 6 over 16, which is going to give us something like, I know I'm running into the room. I should have worked it a little more organized. That's okay. 4 over 16, which is 1/4, and negative 8 over 16, which is negative 1/2. And there's our solution set for x. X could be both of those numbers, so x equals negative 1/2, x equals 1/4, also known as the solution set of negative 1/2 comma 1/4. That's the quadratic formula. Plugging and chugging in numbers into that equation. I think I have a really cool note that I always like to mention at the bottom about this thing called the discriminant, and it's that quantity that appears underneath the square root. And so the note in our brains is, okay, well, what happens if that quantity is a negative number? So what happens if we get a negative number underneath the square root? We spent some time talking about that in class, but if you get a negative number underneath the square root in any class, automatically we know it's an imaginary number. It's really hard to graph and really hard to solve. So we worked on how to solve them, but we don't know how to graph them yet. So what we're going to do is, if it's less than 0, I'm going to do that one first because that's the bad case, right? If the discriminant is less than 0, then you have a negative, I'm writing it all out in words, under the square root. Then you have a negative under the square root, which means we can't solve it. So it means there's no real solutions, but if you would guess it, it means there's two imaginary solutions. So then the next case makes a little bit of sense. If it's positive, which is what we just did like 3 times, if you have a positive underneath the square root, then 2 real solutions, because you can solve it, right? We do know how to solve it when there's a positive under the square root. We just take that plus, the plus and the minus gives us 2 solutions. I'll write it out. Solutions. So then the next question is, what about 0? 0 is kind of a weird one, right? Because if you put a 0 under the square root, we know the square root of 0 is 0, which means it cancels that whole term out. So then we'd just be left with negative b plus or minus the square root of 0 all over 2a. That just goes away. So we're left with negative b over 2a is our solution. And because b and a are whole numbers, or real numbers, that means there's one real solution. I think it's just a cool note to make on the quadratic formula. And maybe you recognize this formula as the formula of something real special later on in class when we start getting graphing parabolas, graphing quadratics. It's the x value of a special point on the parabola. Okay, so here's just some examples saying use the discriminant to determine the number of solutions. The discriminant, like we said, is the thing underneath the square root, so negative b plus or minus square root of 4b squared minus 4ac. So literally just plug in some of those numbers we got. We're not doing the square root, right? We're just doing the discriminant. So you got 4 squared minus 4 times 3 times negative 5, which is going to be 16 plus 60, which is probably like 76, which is a positive number. So there's 2 real would be our answer there. 2 real solutions. That's kind of easier section. If you can do the quadratic formula, you can definitely do that. And then last but not least, in this section of our book, they gave us the Pythagorean Theorem to review. Hopefully it is review. If it's not, let's practice. Come to office hours. We'll practice it sometimes. But it's basically the quadratic formula is this old right triangle. When you have a right angle connected by a hypotenuse, a right triangle can always follows the formula. A squared plus b squared equals c squared, when c squared is the hypotenuse. That's the important thing. Or c is the hypotenuse. That's the most important thing, is that you know that the two edges touching the right angle aren't C. C is the longer side. And you can see that in that picture right there. So here we go. We're just going to do a TV example. Did you know the size of a TV screen is the diagonal? I'll draw a picture up here. It says if the length of the TV screen is 28 inches, boom, 28 inches. And the width is 15.7, boom, 15.7 inches. What is the size of the screen to the nearest inch? So it's asking us about that diagonal. Well, there we go. We're just going to do a squared plus b squared equals c squared. So 15.7 squared, if I call that my a, and I call the other side my b, plus 28 squared equals c squared. How do you get c by itself? We just said square root, square root. Okay, this is interesting because we might actually want to think about that plus or that minus, but obviously a length can't be negative, so we're going to just take the plus side. But it is good to think about. C equals the square root of 15.7 squared plus 28 squared. Now, on your test or your quizzes, you'll have nice, neat numbers. I know this isn't one. This is just from the book. So feel free to hop over to Google or hop over to a calculator and just check and make sure that you can do the maths good. Let me see. I'm going to pull up. I'm going to type it in so I know what the answer is, so I'm not just leaving you hanging. So we're looking at the square root of, right? Square root of 15.7. Square root of 15.7 squared plus 28 squared. Let's make sure it's typed in all good. 32.1. Anybody else get the same thing? All right. 32. Technically 101, and it keeps going. So 32.101, and then we got ourselves what? What's it measuring? Always good to think about your units. 32.101 inches. Oh, that makes sense. TV screens usually are a 32-inch TV screen. So, all right, hopefully that's helpful. If you need more help or you need me to work more problems, they're all solved online on the notes. But for the sake of being able to watch the whole video, we only did one of each type. If you need to come to office hours and work on some of these problems, I'm happy to print out 100 practice of each type. And we can just work through them together, work them on a whiteboard, on the computer, whatever's best for you. So please, please, please practice the suggested homeworks, practice the real homeworks, practice this kind of stuff, go through and do the problems we didn't do together before you look at the answer, because the best thing you can do is try to learn on your own and not copy down answers from me. So I'll see you soon. See you in class. Thanks for watching.